Hello, I am Rafal Sanecki from IS Wireless, and today I'll be discussing energy consumption in O-RAN deployments and some measurements we took at the O-RAN Global PlugFest with i14Y Lab. As an introduction, a few words about us. IS Wireless provides end-to-end mobile network solutions tailored for private 5G, mission-critical communications and campus-wide connectivity. Our flagship innovation, Liquid RAN, introduces a new generation of open, disaggregated radio access built to maximize computing and spectrum efficiency. This architecture not only reduces energy use and capex in everyday operations, but also enhances network resilience under stress or emergency conditions critical for defense, disaster recovery, and other high-stakes environments. We are part of the Netherlands 6G Future Network Services Program, a recognized NATO DIANA innovator, and a proud recipient of the European Commission's Seal of Excellence. We are happy to deliver private 5G for you. Energy efficiency is a hot topic, especially with the increasing focus on sustainability. At the O-RAN Global PlugFest, IS Wireless conducted some detailed measurements on energy consumption in an end-to-end O-RAN setup. This is crucial because while Open RAN offers flexibility and vendor diversity, it's important to understand its energy profile. Our setup involved IS Wireless OCU ODU, a Benetel Radio Unit, and an Open5GS standalone core deployed by IS Wireless. We used a OnePlus phone as the user equipment for our tests. The key here was to measure the power consumption of the entire setup under different load conditions. To get accurate measurements, we used a combination of tools. For the CUDU, which runs on pods, we used Kepler and Grafana. For the whole setup measurements, including hardware, we used Redfish. This allowed us to get a comprehensive view of where the power was being consumed. We designed two main tests. In both, we varied the CPU core allocation to the CUDU pods and applied different traffic loads by changing the DL-PRB utilization. This helped us see how power consumption scales with load and CPU resources. In test 1, we had a basic CUDU split and scaled the CPU cores. In test 2, we split the CU into CUCP and CUUP and again scaled the CPU cores. We look at scenarios with scaled up and scaled down CPU with different PRB utilizations. We primarily focus on PRB usage and UE throughput. These are important indicators of how efficiently the radio resources are being utilized. We measured this under the different load conditions in both test 1 and test 2. What we saw was that, as expected, as PRB usage increased, the UE throughput also increased. We have some graphs showing the relationship between PRB usage and data throughput, with measurements taken at 30%, 50%, and 100% PRB utilization. Throughput was broadly similar across both tests for the same PRB utilization, showing that the CU split didn't negatively impact performance. We observed that power consumption, as captured by both Kepler and Redfish, varied significantly with the load. As expected, the lower power consumption was in the no-load condition, and the highest was at 100% PRB utilization. We also noticed that Redfish consistently recorded higher power consumption than Kepler. This is because Redfish measures the power of the entire hardware layer, while Kepler focuses specifically on the CUDU pods. Redfish gives a more holistic view. It includes the power of components beyond just the CUDU. In fact, we observed a significant power offset around 83 watts, which was consumed by other pods when the CU and DU were not running. There was also a difference of around 92 watts between the total power recorded by Redfish and the power of the CU-DU pods measured by Kepler. This is an important point to highlight. To summarize, we learned several key things. Network conditions like blur and MCS have a direct impact on UE throughput and PRB usage, which in turn affects power consumption. We saw power consumption change with load in both Kepler and Redfish measurements. The difference in power consumption between the 100% load and no load conditions was about 18 watts for Kepler and around 14 watts for Redfish. Interestingly, test number 2 with the CU split showed slightly higher power consumption, about 7 watts more, than test number 1. The most important takeaway is the difference between what Redfish and Kepler measure. Redfish measures the entire hardware layer, while Kepler measures only the selected pods. This explains the difference in their readings. It's crucial to understand what each tool is measuring to get an accurate picture of power consumption. This has been very insightful. It's clear that understanding energy consumption in Open RAN is critical, and the measurements we've shared provide valuable data. Thank you for listening. If you want to continue the discussion, just reach out. Thank you.